Hello, everybody. Welcome to our RAG Hack live streams.
RAG Hack is a free global hackathon happening from September 3rd to 16th. RAG is a technique to get a large language model to answer questions based off your data. We have more than 25 live streams teaching you how to build RAG apps with different Microsoft technologies, plus 10 cash prizes for the best RAG apps in each category. So we're super excited to have you join us for this RAG Hack. And now a word from our friends at Reactor.
Hey everyone, thanks for joining us for the next session of our RAG Hack, Build an OpenAI Code Interpreter for Python. My name is Anna. I'm an event planner for Reactor, joining you from Redmond, Washington. Before we start, I have some quick housekeeping. Please take a moment to read our code of conduct. We seek to provide a respectful environment for both our audience and presenters. While we absolutely encourage engagement in the chat, we ask that you please be mindful of your commentary, remain professional and on topic. Keep an eye on that chat. We'll be dropping helpful links and checking for questions for our presenter to answer live. Our session is being recorded. It will be available to view on demand on the Microsoft Reactor YouTube channel. With that, I'll turn it over to our presenter. Anthony, thank you so much for joining us today.
Hey, thanks for having me. All right, so I am a PM on a product on Azure called Azure Container Apps. Today, we're going to walk through how to build a RAG application using Langchain, and then we're going to add a code interpreter to it to make it do more things and be smarter. So that's going to plan of the day. I think Pamela's in the chat. She's going to pop in here and there. And I think we're just going to get started. Okay, so here's my slides. So we're going to quickly just walk through the app that we're building today. And yeah, with pictures. And then we're actually going to jump in the code. So so to build a RAG application, the first thing that we're going to kind of look at is a Python script that takes some documents, in this case, PDFs, chunk them up, generate some embeddings, and then insert these documents into a vector store. And the vector store that we're using today is Azure AI Search. And it's going to use Azure OpenAI to generate the embeddings. So yeah, like I was saying, it's going to basically load one or more PDFs, and then it's going to call OpenAI to generate the embeddings, and then insert these documents and their embeddings into Azure AI Search. So that's the first step. That kind of loads our databases with these documents so that our front-end chat application can use it. Like I saw that there's quite a few sessions on RAG already, so I won't go too deep into how these things work. You've probably seen quite a few of these already during these past couple of weeks. And then what we're going to have is a front-end app. It's built using this framework called Chainlet. It's really an easy way of building a chat interface in front of your AI agent. In this case, I'm going to build the AI agent using Langchain. And then when like a user starts talking to the app, asks it a question or something, it's going to use OpenAI. In this case, GPT-3.5. I think I could have used GPT-4, but my demo was using GPT-3.5 fine before. I didn't want to touch it, so that's what we got today. It's basically going to use that to kind of figure out what to do with it. In most cases, it's going to realize that, hey, I need to go and look up some information in my vector database. And then Langchain is actually going to go ahead and do that using a tool. And then based on the results that came back from the vector database, it's going to give us an answer in natural language. That's really the whole app. And then as we kind of move on, we're actually going to add a code interpreter to this. We'll kind of cover that in maybe the second half of this hour. And then we're also going to talk about how to deploy this to the cloud. All right. Oh, too soon. We'll get there soon. Okay. So let's look at the code. So I'll start off with, there's really just like three main files here that I want to go through. The first one is this thing I call common.python.py. And it's really just loading a bunch of, or initializing a couple of objects here. So the first thing that I'm going to do is I load a bunch of environment variables. The first thing that I'll do is I'll set up the OpenAI embeddings. And here I'm just using Langchain's built-in tools for this. And I'm configuring that with my OpenAI deployment in Azure. This works fine with OpenAI. It's that's not in Azure as well. But today I'm going to be using Azure OpenAI. And then down here, I'm also setting up a vector store. In this case, like I was saying, I'm using Azure AI Search. And then as part of creating this vector store, I obviously have to give it the actual endpoint to my Azure AI Search instance. And I'm also going to give it its embeddings that I just kind of created above. So whenever it's inserting a document into the vector store or is looking something up, it's actually going to use that embedding function to generate embeddings. And I think that's about it. Actually, before I go too far, I want to go to my browser and kind of show you my a couple of things I've set up already in Azure. So I'm using Azure OpenAI. So in here somewhere, I can open up my OpenAI Studio, and I can show you the two deployments or models that I've set up in here. So in here, I can look at my deployments. And you can see I've set up my GPT-3.5 Turbo, as well as my embeddings model. And then I've also set up an AI search service. And in here, you can see I already have a couple of indexes created. I think this is the one that we're using today. It already has some data loaded. I'll show you how to load the data, though. But this is the index that we're using today. Cool. So let's switch back to our application. So I've kind of gone through kind of like the common setup. So the reason I call this common is because both the job that's going to load the data into the vector store, as well as the front-end chat app, are going to share these things that I just created here. So let's take a look at the indexer job. So this is the job that's going to go and it's going to actually go look in a folder locally. And here I can show you that I have a couple of PDFs in here. They're just like, fictitious company data or information. You might have seen these in other talks already. And we're going to load that into our vector store. So we're basically just, looping over the files in that folder. We are loading the PDF, and then we're splitting them into chunks so that each chunk becomes a document in our data in our vector store. And then down here, I am adding the documents to the vector store. And I was saying before, when it's doing that, it's actually going to call OpenAI to generate the embeddings before it does it, so that it can store the embeddings as well. And another thing that I want to call out up here is that whenever I'm loading a document, I'm basically deleting like a PDF document. I'm actually deleting all the documents inside of our data store, our vector store, relating to that same file, just so that I don't keep uploading duplicate information to my vector store. And that's about it. It's pretty simple, about 40 lines with generous spacing, and I've kind of loaded my vector store. So actually, I can probably run this. Let's run this script. So I'll go Python indexer job.py. When I run this, hopefully it'll do the right thing. So it's going to start up. It might take a few seconds to initialize some of the things I have set up. Usually runs faster than this. Oh, there it goes. yeah, so you can see that it's read in the files, and it's deleting the documents in the vector data store before it adds them back. And then same thing with, I have no idea what this error message is. This started showing up a couple days ago, but everything's fine. Don't look here, ignore my problems. I've kind of reloaded the same documents into the database. And if I want to load more data, I can put more PDFs in here and rerun this thing, and it's going to load more data in there. But yeah, so that's kind of how easy it is to load data into our vector store. And later on, I'm going to talk about how you can run this in the cloud. Typically, you can run this either on demand whenever you upload a file, or you can just run this on a schedule so that it keeps refreshing the search index throughout the day as you add and remove documents from there. All right, so that is the job that loads the documents into the vector store. So let's go back to our diagram. So we basically looked at this part. So now the next thing that we're going to look at is our front-end application that's built with Chainlit and Langchain. So let's go over here to chatapp.py. And you can see here, I'm also importing the vector store that I created in Common. And then I'm setting up a couple of things here. It's actually pretty simple. So this is, I'm using, like I was saying before, I'm using a framework called Chainlit to render my chat UI. It's pretty easy to use. You can see that I just more or less just pulled in Chainlit. And then it has a couple of like lifecycle hooks, I guess you can call them. So whenever a chat session starts, it's going to go load up an LLM in this case, or kind of initialize an LLM. This one I'm using an Azure OpenAI GPT-3.5 Turbo model. And then I'm also setting up a retriever. So my agent actually takes one or more tools. So I'll kind of walk through this in a little bit. But in this case, I'm creating a retriever tool. And I'm providing this to my agent. So my agent will know that whenever I need to look up data, whenever it needs to look up data, it can call out to this retriever tool, which behind the scenes is going to call into the vector store and return any relevant documents to the LLM or to the agent so that it can kind of figure out a proper answer from that. So here, I'm creating an agent in Langchain, and I'm providing my LLM that I created earlier. I'm also providing it my tools. Right now, I only have one tool, which is the retriever tool, which talks to my Azure AI search. And then a prompt. I'll quickly show you the prompt. I'm using a custom prompt, but I think you can probably use an off-the-shelf one and it's fine. I'm basically telling it that, hey, I'm trying to be nice to it. I'm saying, hey, you're a helpful assistant. Please answer the questions as best as you can, and you have access to these tools. And then I'm basically, telling it what tools it has access to. And then I'm basically using this pattern called React to kind of like have it kind of like generate questions and actions and observations based on the questions that they were asking it, so that it has a like a format to follow as it's trying to figure out the answer to my questions. And then that's about it. So that's really my prompt. And yeah, usually you don't even see the prompt because Langchain actually has a hub that you can pull down these pre-made prompts from. So you just kind of like reference a pre-made prompt, and it usually works pretty well. But I just kind of want to show you like what a custom prompt looks like. And then from there, I am creating an executor for my agent, and I'm kind of passing similar things to it. And then that's about it. That's really like all I need to do to kind of set up my chat session. So every time I open up, or your user opens up the chat session window, that's the code that gets run. And then when on every message that comes through, this is Chainlit is going to invoke this function here. We're going to ignore this stuff up top. Just pretend it's not there. That's for later. The important part here really is just this chunk of code here, which is I'm going to go invoke my agent with the message that I've typed in. And that's about it. And then we're going to get the response, and we're just going to render it onto the screen. Chainlit also allows us to render like additional information about what happened in the when it was kind of like figuring out the answer, so that we can better or more easily see it. So so that's what I'm doing here. I'm kind of rendering the intermediate steps that the agent is taking, and we'll be able to see that in a minute. And that's it. So I'm going to go and open up this thing. Once again, ignore this error that I had before. And I'm going to run chainlit, and I will start my app. Hopefully it's going to start a little faster than the job, because that took a while. I ran out of things to say as I was stalling. Looks like this is taking a bit too, but it's almost there. Waiting for one more line saying that it's started. You can do it. Oh, there it is. Okay, so I'm going to go to localhost. Of course, it opened it in the wrong window. Let me find my browser, and I'll just navigate there myself. Okay, so this is my chat app, and I can, so I already loaded some data, using my job, so I should be able to query it. So I can ask it about, what company do I have info about? And hopefully it's doing something. Let's take a look at, yep, it did. Oh, there it is. So it gave me the answer. And you can see that it decided to use the search documents tool, basically the retriever tool that I gave it. Well, it's really the only tool that it has access to. And then it kind of submitted a query named, or like called a query that was that says company information to the Azure AI Search, and then Azure AI Search returned a few documents relating to that, and then the LLM basically looked through it and decided that the answer is, the company is called Contoso Electronics. So we can ask it more information. So I loaded some information about roles. Maybe I can say, like, what roles are there in Contoso? And you can sort of expect it kind of, it kind of probably executed a query about roles in Contoso, and then it kind of came back with a bunch of documents, and then it summarized those documents in an answer. So we'll just ask one more question, and then maybe that's about it. So maybe we can ask it about one of these people. What does the director of HR do? And it should, yeah. So it kind of got some information about that. So so yeah, that's really like the end-to-end of loading some data into Azure AI Search, and then also kind of querying that using Chainlit and Langchain. So hopefully that's that's new to you. That's great. I know that there's already been a few different presentations about RAG during these past week or so. So for some of you, this might be review. But now we're going to kind of jump to how we deploy this app to the cloud. In this case, we're going to talk about how to deploy this to Azure, and then we're going to talk about how we can add a code interpreter to make it smarter. All right, so no, I don't want to see this. Back to my slides. So I just want to quickly kind of talk through Azure Container Apps, which is the current service in Azure that I'm working with. And yes, and that's what we're going to deploy our application to. So it's a place, as you can kind of figure out from the name, it's a place to run serverless containers in Azure. And so you can actually, deploy really any kind of container, anything that you can put into a Docker container in Azure really easily. So you don't have to think about any infrastructure at all. And because it's serverless, we actually scale dynamically for you on your behalf. So I just want to kind of quickly touch on what serverless means in case that's new for some of you. So the key thing is you don't really think about servers, so you don't think about the infrastructure at all, and you have access to instant scale. That's both being able to scale to like a lot of instances when you have a lot of work to do, and we're also able to scale to zero when there's really nothing to work on. So it's really efficient. And it's pay per use. So if nothing's going on, you don't pay anything. And then during the the moments where things are happening, and your app is actually processing things or serving HTTP requests, that's when you pay like fractions of a penny per second. Cool, and just a quick kind of roundup of things you can run in container apps. Like I was saying, pretty much anything you can put into a Docker container you can run. So a lot of folks run like microservice like applications in there. You can run a single like large application in there. You can run web apps. You can run things that process events. We're seeing a lot of people deploy AI applications to it because as you'll see later on, it has kind of all the all the building blocks that you need to run an AI or intelligent application, and really backends and things like that. Right. So I'm just going to give you a quick overview about all the different components within Azure Container Apps, and then we're going to go back into our application and learn more about how to work with that. So like I was saying before, you can deploy like things like a web app or an API to container apps in this thing called an environment. So you can deploy one or more apps into an environment, and all these apps they share logging and things like that. And they also share the same networking. So these apps can actually talk to each other. So we do this by basically making app-to-app calls. So in this case, if it, like for an external user, maybe they're actually accessing the front end, and they do this through this thing called an ingress. So they basically just make a regular HTTP call, and then we serve our front-end app. But maybe our front-end app actually calls our web API, and it can do that actually through a private network. You can deploy other things into a container apps environment as well. So you can you can deploy a background process that just kind of sits around and processes the things off of a queue, and or things of that nature. Or you can run jobs. So so it's like kind of like the script that I ran earlier to load our vector database. You can actually run that as a scheduled job within the environment. So only when it wakes up and needs to run do you actually pay for it. Otherwise, it's completely free, just kind of sitting there waiting for the next time that it needs to run. So so in our application, we're going to deploy the front end, or kind of like our chat app, as basically a regular container app like this front end here. And then we're going to deploy our the job that indexes all the PDFs as a scheduled job. I think that's all I want to. Yep, that's all I kind of wanted to talk about. And then I'll kind of quickly walk through what it looks like in Azure. So I've deployed a bunch of resources. I won't focus on all of them. I'll kind of quickly open up our environment. I was actually testing out some bicep deployment, and I decided to generate a random name for it. So that's why it looks kind of funny. But yeah, so within my environment, you can see that I've deployed a couple of things. The first thing is I deployed my job. So I literally took my application over here. I have a Docker file for it. I basically, just built my container using this Docker file. And this Docker file has both the front end as well as the job in it. So I'm actually using the same container for both the app and the job to keep things simple. So so here's my indexer job. If I go into it, you can see that I'm using my chat app container somewhere. And I can also see my execution history. And you can see that I think every 5 minutes or so, my job is starting up and it's running, and it's basically re-indexing the the documents that that I was loading. And it does this by actually loading it instead of from the hard drive like I was doing locally. It's actually doing this using a file share in Azure. So I can actually go and push more files into my file share, and then in 5 minutes or so, the job is going to run again and load my new files. So that's kind of how it works for the job. I'll kind of quickly to look at the chat app as well. So this is the chat app. And is there too much I'm going to show you here? Probably not. So it has a URL. So if I actually go to this URL, for some reason it's rendering in dark mode, but I promise you this is the same application. So what roles are there in Contoso? I should come up with more questions than just the same 3 over and over again, but you can see it's working in the cloud as well. Cool. So I'm going to pause here. Just want to see if Pamela or anyone saw any questions.
Yeah, we don't have any questions so far. We're just chatting.
Awesome. Okay. Well, I'm going to keep going then. Thanks, Pamela. So we've kind of looked at how we kind of deployed our application to Azure. So now let's talk about how to make this thing smarter. So so this is kind of like our current application, and the chat app is free to ask Azure AI search whenever it needs information, but sometimes it needs to do more than just reading information and summarizing it. Maybe it needs to do some computation. Maybe it needs to maybe do some math. Maybe we want it to process like a PDF or a CSV file that has some data, so that we can actually chat with the CSV file. We can't really do this by loading the CSV into AI search, because at the end of the day it's kind of returning static data, right? So we actually need a way of actually doing some processing or computations. So what we can do is actually we can give our app access to a Python code interpreter. So what that means is when you ask our application a question, our agent, Langchain is going to go and see the question and be like, is this a question about information I can look up in my vector database, or is this something that I can write some Python code to actually solve the problem? So we're actually going to show you how to add a Python code interpreter to our app. So let's do that now. Let's go here. All right, so back to our chat app. You might have noticed that I actually had a section here hidden that kind of sets up a second tool, which is a code interpreter. So out of the box within Langchain, it actually already provides a Python REPL tool that you can just bring into your app. I'm actually augmenting its description a little bit to make it work a little bit better. But for the most part, you just bring in this tool, and then we can provide this tool to my Langchain agent. So everything stays the same. I haven't really done anything else. I just added these 3 lines of code, and now these same tools are going to get passed to my agent. And now my agent is going to have access to 2 tools whenever I ask the questions. So I'm going to stop my app and start it again. Hopefully it'll start up faster. Maybe not. Oh, there it goes. Oh, I haven't seen those errors before. It looks like it's working. All right. I'm going to ignore those errors too. Let's go back to my browser and make sure I go to my local host. I'll refresh it so I get a brand new chat session. And this time, I think I should still be able to ask the same questions as I did before. And I think it should still choose to use the vector store to answer my question. But let's see. There you go. And if we look at the details of the execution, oh my, actually, that's interesting. It actually, yeah, so it kind of queried the data store or the vector store for some information about the director of VicChar in this case, and it got some information back. But for some reason, it decided to use the Python REPL to answer your question, which is fine.
Yeah, that's actually a question from John. Is that how does it decide which tool to use?
Okay. So there's we can actually see this. Yeah, that's a great question. Let's do that. So don't know if there's an easy way to check it though. Let's see. There should be. So in this retriever tool thing. Like this thing I know how to get to. So for the Python REPL tool, you can see that it has the description.
Mm-hmm.
And yeah, so we're basically telling it that, hey, like, this is a Python shell. Use this if you need to figure something out that you can write some Python code to figure out. So that's that. And yeah, and I don't know how to get to the other one. Let's see if I can. Maybe not. Like, I can write some code to kind of print it out. But like, so basically every tool has a description. And in our prompt, and you won't be able to see this in the prompt, I don't think. But what it does is that this part here gets replaced by both the tool's name as well as the description. So the LLM will know that not only the names of the tools that it has access to, but a description of the tool. So now really, it's now up to the LLM to kind of choose the tool to use. And then based on what it decides to use, it's actually going to respond in a certain format because we told it to. And then basically, Langchain is able to make sense of the response and know which tool to invoke. And then kind of grab the results from that tool and then give it to, give it back to the LLM to kind of figure out what the next step is.
So it looks like in the one that you just did, that the issue is that the previous step gave Python code. And of course, when it saw Python code, it thought it should use the code interpreter. So somehow the retriever responded with a print statement, it looked like, right?
Yeah, and actually not quite. I think it did something different. So this is basically what came back from the first tool call, which was about a few documents about what the director of VicChar does. And then it looks like the LLM decided, instead of printing, like basically summarizing and printing that information, just basically returning that as the answer, it decided to ask the Python REPL to print the answer it would have told, like it would have returned. So basically, it decided to waste extra CPU by doing this, because it just literally printed the same thing back, and then says, "Oh, okay, now I know the answer." Of course, you know the answer because you told it the answer. But anyway, so it's really interesting what this thing does, because it's really unpredictable what it decides to do. So let me run this app again, so we can kind of show you what else it can do. So one thing I didn't show, I think I should have done this earlier, is that if you ask it a math question without and it doesn't have a Python REPL tool, it's actually still going to give you an answer, but it's actually an answer that it's sort of hallucinated and made up. It looks real, but it actually ends up being wrong, and you don't know it's wrong until you punch it into a calculator.
Can you ask it how many R's are in strawberry?
Oh,
and then have it generate the Python code for it?
That is a great question. Okay, I've never tried that. That's perfect. Okay, so let me start again. How many R's are there in strawberry?
It's going to try to retrieve for this one, isn't it? Let's see.
Oh, we'll see. We'll see.
Got both tools. Is it allowed to skip straight to the REPL?
Yeah, it's going to choose based on the question we ask. So ideally it will, you know, like maybe if we kind of hint and say calculate how many or count. There are 3 R's. Let's see what it did. Let's see what it did. I'm really
correct.
curious. So it actually did try to search, and it probably came back with nothing useful.
Okay.
And then it decided, oh, okay, that was a waste of time to search for this, to search the vector store for this answer. Let me now write some Python code to figure this out. So it actually wrote the Python code. That's strawberry.count R, and yeah, and that's how it kind of came up with the 3. So it basically returned 3 to the LLM, and the LLM basically formatted that into a human readable answer. So
this is cool. Great.
Yeah, I haven't tried this before. It was cool. Yeah, and like I was saying, you can kind of do math and then just punch in some really large number. And you're gonna have to believe me on this one because I'm not gonna stop and start my app again. But like, if I didn't give it a Python REPL, it will actually give you a very similar answer, but it's probably wrong because it just kind of guessed it. Like not even guessed it, but it kind of just did the text generation thing that an LLM is good at, and kind of hallucinates an answer. But in this case, it knows that it has access to a Python REPL, so it's able to basically generate the Python code to do it, and pass it to the Python REPL. Okay, so that's great.
So John is actually wondering, how do you make the LLM say its steps? That's coming from Langchain? Or
yeah, so that's this part here. So Langchain has a way of kind of returning the intermediate steps. So if I go back to my chat app, go down here. So after I kind of run this invocation, I can actually grab the intermediate steps from it. And all I'm doing is I'm just kind of concatenating that together and kind of chainlet the framework I'm using to render the UI has a way of displaying that. That's kind of how I'm doing this. That's a great question. Yeah, so that's that. But can you think of why or things that can go wrong if I were to run this app in production?
Well, where are you executing the Python code right now?
It's running in the same process as my as my application. So in this case, my computer. And then when I deploy it to the cloud, it would be kind of like in the same process space as my server.
Right. So that's really bad.
Is it bad? I was about to deploy this in production. What are you talking about?
If you can get it to, this is a fun form of injection where I think I got you to do this before, like get it to run sys.process, like what is it, like sys.process kill -1 -f, right? Like you can,
I'm not gonna do that.
Like run code on your machine. You could get it to like just even writing a really, really long infinite loop, right? Or near infinite loop, something that's a very high intensive processing.
Wow, I haven't thought of those ones. Actually, you're very evil. But yeah, like you're totally right. You can basically, like because it takes input from a user, the user can trick it into doing stuff. So I'm not going to do the one where it deletes all my files because it's literally running on my machine. But I can actually do things like sometimes it works, sometimes it doesn't. But like print the contents of the file .env. So I'll have some environment variables stored here. Yeah, look, it actually opened up my env file and printed out that information. Thankfully, I'm using managed identities, which means there are no secrets in my application. So so my environment variables aren't actually secrets. So that's why I'm able to kind of print this out. But you can kind of imagine it's kind of printing out a file that has actual secrets, or it dumping the actual environment variables out from your application. It can do all of that. And of course, you can ask it to delete all my files. Which would be really bad. I think if I did that, then I think the stream would be over. So I won't do that. But that's why you don't want to run this in production. So so the next thing we're going to talk about is, what can we do? How can we run this thing in production and do it safely and not do what we just did here? So let's go back to my slides and we'll kind of quickly talk through that. Oh, I was apparently supposed to do a demo. So yeah, we just talked about some of the concerns, for running LLM generated code in production. LLM generated code is quite unpredictable, as you kind of saw earlier. It decided to, print some stuff. It decided to, do all sorts of things. yeah, so and then also it can take malicious user input that can trick it into doing even more evil stuff. So we definitely don't want to do what we did there, which is run it in the same process as our app, because really bad things could happen. So so that's the first one. We have to worry about security. We also have to worry about performance. Say I'm actually serving, like not just one person's chat, but like say 100, and they're all kind of running Python code. How do we make sure that whether we're running it for one or 100 at a time, that we still get the same performance. And then quite often what this means is that you actually have to create different places to run each of these like the code, like the LLM generated code for each user. So you could spin up a container somewhere to run this code, for example. But say you did spin up containers to run this code, how do you decide when to when to shut them down? So you have to start kind of worrying about the lifecycle management of all these environments that you're spinning up just to run this code securely. And then scalability kind of ties into it as well. So can you run this at scale? So as we saw earlier, container apps, we have a couple of things you can deploy. You can deploy apps, which are basically things like web servers and things and like services that kind of run pretty much forever. Those deploy as apps. Or you can have jobs, which are kind of like things like maybe a Python script that runs, does something, and then exits. So those are kind of like the two things that we can actually run in container apps. There is actually some forms of isolation that's already inherently in the platform, but but it's not actually super easy to, for example, spin up a job for every user's code, because it does take take a few seconds to spin up the job. And also, how long does the job run for? Do you keep it around? Do you create a new one every time? It's kind of complicated. So we actually looked at this problem, and then we decided to add a new primitive to Azure Container Apps to solve it, and we call it dynamic sessions. So what you're able to do is you're actually able to basically grab what we call a session really easily from the platform. And it can be like a session that has a Python interpreter in it. You can get one of those things, and then you can kind of send it some Python code, and it'll return you the result. And then for every user, you can actually grab a different session, and each of these sessions are fully isolated. So let's kind of take a look at how dynamic sessions solves these problems. So security. So every session, so like every time you request a session, you actually get a container that's fully isolated using Hyper-V, which is one of the strongest forms of isolation in the cloud today. So you don't have to worry about it running in the same process as your application. And it can run the code in milliseconds. So when you send it some code, it will actually run and give you the results in milliseconds, whether the session that you're sending it to currently exists or not. If you send it, like to a brand new session, say you have a new user that's asking a question, and they don't have we don't have a session running for it to run this Python code. It'll actually spin up a session within milliseconds to run this code. And then it actually gives you a way of managing the life cycles as well automatically. So when you spin up these sessions, you don't have to worry about how to get rid of them. By default, you can actually configure what's called a cooldown period. So after you're done running, your Python code or whatever in these sessions, the platform actually realizes that you haven't used this for a while, and then it'll start cleaning them up automatically for you. So you don't have to really think about it at all. You just use it. And for scalability, we're actually using this in a bunch of different internal projects within Microsoft. And I'm pretty sure you probably tried some of these projects externally that are actually using sessions. You just don't know it. So it's actually running at a scale of sometimes millions of sessions a day through our different products. So we're basically just giving you this platform that we're using internally so that you can all add it to your apps as well. So just really quickly, dynamic sessions are kind of available in two modes. So the one that we're going to focus on is the one on the left, which is a code interpreter. we see a lot of customers and developers wanting to use a code interpreter. So we made that easy. So you don't have to manage a container at all. You just come to us and say, hey, I want access to some Python code interpreter sessions. And then that's it. You have access to them. But if you want to run something else, say you wanted to run, a code interpreter for a different language, or you wanted to run, like a specialized Python code interpreter that has your own packages in it and things like that, you can create a new, a custom container. And custom containers can do even more. So anytime that you need like isolated, like strongly isolated sandboxes for each user. So think things like, if I wanted to build my own GitHub code spaces, for example, or, build my own, Azure Cloud Shell, I can actually use dynamic sessions with a custom container to build a platform like that pretty easily. So, we're into our last 14 minutes here. So I want to kind of make sure we cover everything. So I'm going to move on. So here's how it's going to work. So this is what we have currently, which is the Python code interpreter running in the same process as my app. That's bad. And we want to make this secure. So what we're going to do is we're going to spin up a dynamic session within container apps that has a Python code interpreter in it for every chat session. And then we're going to, and then basically our app is going to call out to that to do any computations. I think that's it. Yep, demo time. Back to my code, the happy place. So I'm going to quickly show you the session first, how to use it. So I've already created one. So in order to use sessions, you just create this thing called a session pool. It doesn't cost you anything. You just create it. It's just a bunch of settings like, how long I want to keep my session around and also how many concurrent sessions I want. So in this case, I can have 50 running at a time. If I wanted to, I can actually go into the playground and kind of try things out. Oh, it looks like I don't have a role. I can add a role automatically. So you can actually use this playground to run code. Sometimes it takes a few seconds for the role assignment to propagate. So this might not work, but let's see. I'm gonna run. You can see that just the time between me clicking the button and getting a response back, that was under a second. That basically allocated me a new session, ran the code in it. So I can actually change like this to something else, to just any other identifier. And when I run this, when I run this code a second time, it's actually going to run it in a second session. So you can see, just within a few milliseconds, it allocated me a new session and ran the code. Cool. So that's that. So that's kind of like how you would, this is kind of like how you create a session pool in Azure. And you can definitely call REST APIs to interact with it. But what we've done is we've actually shipped integrations with Langchain, Llama Index, Semantic Kernel, and some other LLM frameworks to make it really easy to use. So I'll kind of quickly show you how that works here. So this is back to my chat app. And back up here, I'm just going to switch out this line of code for a session Python REPL tool. And this thing needs a pool management endpoint. And that should be it right there. So I'm just going to swap out that one line of code. Instead of the built-in Python code interpreter, I'm now using a sessions Python REPL tool. And I'm going to go ahead and stop this app and run it again. So while this thing is starting up, I will show you something else that I'm doing. So one thing I didn't show you earlier is that you can actually tell it to you can actually ask the LLM to say, open up a CSV file and actually, kind of, query it and kind of like give you an answer from there. If I had like pandas or something installed. So within dynamic sessions, we actually have like hundreds of Python libraries and packages pre-installed, including pandas. So we can actually, what we can do is that we can actually upload a file to the session and then ask it questions, like for instance, like a CSV file, we can actually ask it questions, and then the LLM should be able to generate pandas code to basically query and come up with answers from our files. So that's what the section that we kind of skipped over earlier is doing. So what I'm doing here is, it might be a little bit hard to read, but this is the key line here. So if through the UI, I can upload a file. So if I upload a file to this chat app, what I'm going to do behind the scenes is basically call my REPL to upload the same file, this file that was given to me, up to the session that I'm using for this user. So now this file lives in the session. So now when the agent writes some code to query it, it's able to read that file and actually give me an answer from that. So here I'm uploading the file, and then I'm also kind of like giving it some extra instructions now that I uploaded the file. So I basically told it a couple things. I basically said, hey, if you need to query or analyze any data, there's a file that got uploaded to wherever this thing is. And then you can execute Python code to read the file, extract the data. You have pandas available. And I'm also telling it that, hey, no matter what you do, the first thing you should do is kind of like look at the shape of the file, like because it has no idea what the columns are in the file. So we're basically telling it, hey, before you start, make sure you always check the first few lines to see what the data looks like, and that's it. So we're just kind of giving it as an extra hint, and where that shows up in the prompt is that it just gets injected in here. So whenever I have a file, the LLM is basically getting a little bit more information about where the file lives. That's it. So that's kind of my hacky way of making this work. And now going back to my application here, I'm going to go and refresh it. So what I'll do is, I'll do the math question again. And what it should do is it should give me the same result, but this time it should be running, like using the session to give me that result. Hopefully, there it goes. You can't really tell from this answer here, but if I go back to look at my output, you just have to trust me on this. This is actually the response from the session itself. So this is how I can tell that it's actually using the session instead of the my local machine. I can also ask
it to print out the EMB.
Yeah, that's a great question.
Let's try that one. And then also, if you could ask it to RM all your files, that'd be great.
No, just in case I messed up somewhere. I don't trust myself. I think you've worked with me enough already. Nobody should trust any code that I write. So I think you probably should trust my code less than you would trust the LLM generated code. Here, look at it. Actually tried to do it, but then it wasn't able to to read it. So because there is no .env file in the session.
So it errored out. So I guess it handles exceptions or knows how to give
and that's actually that's a good question. There's actually some settings here where I'm actually handling parsing errors and things like that, so that it doesn't just crash. So now I'm gonna try to do this file upload thing. So I'm gonna go ahead and choose a file. So I have like this customers.csv file. I'm gonna ask this thing like how many customers are there in the data? And so the first thing it's going to do, because this message has a file, like it's going to run that line of code to push the file up to the session. And then it's going to carry on, and basically the LLMs is going to do whatever it needs to do. In this case, it decided that it needs to run some pandas code, or so here, so it followed my instructions. It first kind of checked the head of the CSV file to see what the what the data looks like. And then based on what it returned, it's able to figure out that, I just need to count the rows. So I'm just going to do a length of the data, and then it kind of returned 1400, and then it kind of gave me the natural language response. We can actually ask it more information. The file is, I don't think I have it open anywhere, but it's basically just a bunch of like fake customer information. So you can say, who are the top 5 customers in sales? Is it by sales, in sales, by purchases, by who bought the most stuff? I think that's that might be the most technical way to say it. So hopefully it's gonna write some code there. So it kind of figured it out. So you can actually see what it's doing. So you can see that first of all, it's going to check the columns first, and then it kind of realizes that the column name that I need to go after is actually called total purchases dollars. So it's not just guessing it, it's actually, using the results of reading the first few lines of the CSV file. And then it's writing the right pandas code to actually generate the answer. And then it's giving me, the users. You can actually, like ask it more complicated things than that, although it's a little bit hit and miss. So you can say like, like there's a column called like satisfaction rating or something. So you can say like, who are the happiest customers in like Arizona or something. Hopefully it'll do the right thing. If not, we'll just ask it twice. He'll probably do the right thing. So so it gave back like, a few people. You kind of see what it's doing. So so it's reading the first few lines again. And now this time it's filtering by state of Arizona. And then it knows that happiest means I need to look in the satisfaction rating column and I need to sort it properly. And then it kind of came back with a few customers, and that's what it printed on the screen. So yeah, so that's kind of like how you can make your agent, quite a bit smarter by giving it a code interpreter, and by giving it a sandbox code interpreter that we provide in Azure Container Apps Dynamic Sessions. You can do this securely as well. So yeah, I think that's all I have from the demo. So I'll kind of quickly go over maybe like 1 or 2 more slides. Maybe there's a link on there somewhere. Yeah, so I was saying before, so those are the types of things you can run in container apps. So yes, this is like the main link you can go to kind of read more about container apps. And then somewhere within the side, you should be able to find dynamic sessions there to learn about the code interpreter. This code is available somewhere. Actually, before I forget, I'll probably just browse there to find it. So I go to my GitHub, go to my repositories, and it's called ACA, which is Azure Container Apps AI Agent. So I'm going to copy this link and share it into the chat. That hopefully somebody can help me share publicly. Now, and I know there's like an internal GitHub discussion thing that we can share this on too. So yeah, so you should be able to. Oh, I guess I lied about adding a README. I thought I added a README. Didn't I add a README? Well, anyway, there should be a README somewhere. Maybe I added it to the wrong place. Oh yeah, I added it to the wrong place. But yeah, so you should just be able to run, the bicep files to create your infrastructure, and then the deploy.sh. I still have to retest the bicep. It might not fully work, but I think most of it's there. But yeah, that's kind of like the whole thing.
All right, we have a question.
Oh, we do.
Yeah, Ashish asked, can we generate fake data through the code interpreter and then do something with it in the next step?
Probably. I can't think of anything.
So the interesting, so normally when I generate fake data, I actually like to use Faker or Mimesis. Those are the two most popular Python packages. I'm guessing those are not part of the default environment, right? I guess we'll find out, but you have like a certain set of packages that you've got pre-installed on this, right?
Yeah, there's quite a few packages, so maybe Faker is installed. Like we'll see. Oh, it did something.
It did something.
Oh no, but it just did some query. What is that?
Okay.
Oh no,
there's
it actually
Faker.
did it.
Yeah,
it's using
there's
Faker.
Fake.word, fake random.
I have no idea why it's using pandas, because it's confused because it's like, make sure you always check the first few columns, which is probably bad instructions. But no, it did use Faker to generate some stuff. Looks like it's real. Looks like it did it. And for some reason, it decided to do like the most expensive, which I never asked for. But whatever, it did something.
Wow. So Faker
maybe not what you wanted.
Yeah. So that would be one approach for generating fake data. I don't know what the exact use case is here, but I mean, generally you want to check to see what are the Python packages on the machine. Do you want to like generate the fake data using just an LLM? I actually usually recommend using something like Faker because it actually has like internationalization built in. So if you're trying to get like fake credit card numbers, it's going to be much more representative of all the different kinds of credit card numbers out there, which is generally better to be more representative.
Okay.
But cool. It's really cool when it worked. I'm so excited about the pandas on CSV because so many people ask about how to add that sort of functionality to their
Yeah.
RAG applications. And
Yeah.
it's the kind of thing that current RAG applications just aren't good at answering, right? They can't answer these like aggregate questions. And
Yeah.
now we have a way of answering these questions.
Yeah, that's super cool.
All right, well, we are at time now, and those are the only questions I saw. So that was super cool. I'm really excited about it. And we will put all the links in that GitHub discussion thread. And if you have any follow-up questions, then you can post in the chat. There's people that everyone just wants you to try different things. So I think we should try to deploy Anthony's repo and then try it yourself, try RMRF, right? Try everything there and then file issues on the repo, with anything you run into, like it doesn't deploy, it doesn't work, whatever, so that we can make this, something that, everyone can deploy and try out.
Awesome.
Great. All right. Thank you, Anthony.
Thanks for having me.
Bye, everyone.
Bye, y'all.
Hey, everyone. Hope you enjoyed today's session.
If you aren't registered yet for RagHack, you can register now at aka.ms/raghack/register, and you can introduce yourself on our forum. You can start hacking either by looking at one of our code samples or just starting from scratch. If you have any questions along the way, feel free to post them in our GitHub discussion forum, and you can also attend live office hours in our Discord. Once your project is ready, make sure to submit it before September 16th at 11:59 p.m. PT to be eligible for our cash prizes. And of course, make sure to join our upcoming live streams to learn more about RAG. Thanks for joining.
Thanks, everyone, for joining. Thanks to our speaker. To learn more about this series, watch past episodes, and register for future sessions, you can follow the link at the bottom of the screen or in the chat. We're always looking to improve our sessions and your experience. If you have any feedback for us, we'd love to hear what you have to say. You can find that link on the screen or in the chat. Today's event code is 23340.